Today we're going to talk about using perpendicular bisectors. Again, if you remember from previous lessons, perpendicular, two things that intersect at a right angle. Bisect means it divides it into two congruent parts. So perpendicular bisector is going to be a segment, ray, line, or plane that is perpendicular to a segment, obviously at its midpoint because it divides it into two congruent parts, and then we call those a perpendicular bisector. Alright, so it must be perpendicular to the segment and it must go through the midpoint. Equidistant. Okay, we've talked about equilateral, equiangular. Well, now we're talking about equidistant. Equidistant, just like kind of the name says. A point is equidistant from two figures if the point is the same distance, equal distance from each figure. Alright, concurrent. This one's pretty significant here because when three or more lines, rays, or segments intersect at the same point, they're called concurrent lines, rays, or segments. So concurrent is significant because you have three or more lines, rays, or segments intersecting at one point. Alright? You know, to have two intersect, not a big deal, but to have three or more intersect at the same point, that's pretty significant. Alright. Where those lines, rays, or segments intersect, that's called the point of concurrency. The point of intersection of concurrent lines, rays, or segments is called the point of concurrency. The point of concurrency for the perpendicular bisectors is the circumcenter. Alright, circumcenter has to do with circumference, going around a figure, and then center, the center of a circle. Alright, circumference talks about a circle, the distance around a circle, and center is the center of the circle. Alright? That's the point of concurrency of the three perpendicular bisectors of the triangle. Alright? Now, first off, if a point is on the perpendicular bisector, point C here, we know point C is on the perpendicular bisector Y. Well, line CP is perpendicular to segment AB, and we know that segment AP is congruent to BP. So we know that P is the midpoint. So yes, point C is on the perpendicular bisector of segment AB. So if a point is on the perpendicular bisector of a segment, then it is equidistant from the endpoints of that segment. So if line CP is the perpendicular bisector of segment AB, and it is, then length CA equals length CB. Alright? And we could show that by proving these two triangles congruent. Alright, we have this segment congruent to that segment. We have right angles, so those two angles are congruent. And segment CP is congruent to segment CP. Congruence is reflexive. So those two triangles are congruent by side, angle, side. And then these two segments would be congruent because of corresponding parts of congruent triangles are congruent. Alright, so now what this theorem does is it tells us we don't need to prove those triangles congruent, because if we simply know that that point's on the perpendicular bisector, we know it's going to be equidistant from the endpoints of the segment. Now the converse of that, alright, if a point is equidistant, so if point D is equidistant from the endpoints of the segment, length AD is equal to length DB, then it is on the perpendicular bisector of that segment. Alright, so if length DA equals length DB, then D lies on the perpendicular bisector, which in this case is line CP. Alright, here we go. Line AC is the perpendicular bisector of segment BD. Now, from that sentence there, what do we know? Alright, we know that it's perpendicular. We know it bisects. Alright, point A is on the perpendicular bisector, so therefore length AB equals length AD. What is the length of AB? That's 7x minus 6. What is the length of AD? That's 4x. Alright, subtract 7x from both sides. You get negative 6 equals negative 3x. Divide by negative 3. X equals 2. And they're asking us to find the length of AD. Well, x is 2. AD is 4x, so we got 4 times 2, so length AD equals 8. Now, in this problem, the diagram line KN is the perpendicular bisector of segment JL. Alright? So these segments are congruent here. Alright, so part A, what segment lengths in the diagram are equal? What lengths are equal? Well, we know because it's the bisector of segment JL, we know that length JN equals length LN. Because point K is on the perpendicular bisector, we know length JK equals length LK. And I'm not kidding about that. Alright? And then lastly, because of the measurements we have in our diagram, we know that length JM equals length LM. Okay? Now the question is, second part, part B, is point M on line KN? And again, we can't assume that this line is going to continue and intersect it. We have to know that. Well, what do we know? Well, we know because if these two lengths are equal, point M is equidistant from the endpoints of segment JL. Right? It's equidistant from the endpoints. Therefore, what do we know about point M? It is on point M is on the perpendicular bisector. Well, of segment JL. Well, which line is that? That is line KN. So yes, it is on line KN. Okay? Alright, now, perpendicular bisectors of a triangle intersect at a point that is equidistant from the vertices of the triangle. Alright, perpendicular bisectors. So, say if segment PD, PE, and PF are perpendicular bisectors. So, perpendicular, congruent. Perpendicular, congruent. Perpendicular, congruent. Alright, they're all perpendicular bisectors. They meet at a point, point P. That is called the point of concurrency. Alright, and in this, point P is the circumcenter. So therefore length PA equals length PC equals length PB. Okay? Alright, please try these problems in your notes and come to class if you have any questions about these problems. Alright? Thank you very much.